about random stuff. Okay. So if Monday was about introducing data, like what do we call it, what are the data types, things like that. Today is summarizing data, which is how do we take that data and summarize it into information and use it usefully, right? That's why I like that Carly Fiorina quote there at the top, saying the goal is to turn data into information and information into insight, right? Because the whole goal of everything we're doing is to get to a point where we have insight and can. Otherwise, everyone has data. We create data at a crazy degree these days. But if you don't use it, you're just turning into a data hoarder, right? You're just one of those people like, yeah, no, we have a lot of data, therefore we must be right. Like, what are you doing with it? Nothing, but we got the most data. Awesome. Like, you can go on like hoarders, and just instead of like rotten newspaper and food, your house is just full of thumb drives and Excel sheets, and some guy going like, oh my gosh, look how many red flags he has of 99,000. Sucks to be him. He's not doing anything with it, right? And so that's what I want to get in this class, is that we actually use it and do things with it. Before we get into anything, let me go through some admin. And actually, while I'm talking, I'm going to I put in just 4 messages in the chat, 1, 2, 3, 4, that are linked to the lesson objectives that I have here for the guided lesson. So if you guys just want to throw some emojis on that, throw an emoji on whichever one you thought was the one that you struggled the most with, or you got the most questions about. So I kind of get an idea of where we're at, where to focus on. While you're doing that, just some admin things. I can't remember. It may have been this class that I misspoke on Monday. One of the classes I incorrectly said that your first lab was due next Tuesday, but that's not true, because I forgot MLK pushes our MT days over. So your guys' lesson 5 is next Wednesday. And so that is when your lab 1 is due at 1700 on Wednesday. Your homework 1 is due today. So make sure you get that done, because like I said, it's probably the easiest points I'm going to throw at you all semester. So just get that done, get on there. With respect to lab 1 next week, it is due 1700 Wednesday, but I highly suggest that you guys start opening it and looking at it today, so that you know what questions you have, because I'm not going to be available on the weekend. Monday is a holiday, and most faculty are being given either Friday or Tuesday off as a leave day, depending on when they teach. So I will be on leave next Tuesday, which means I'll be available between M3 and 1700 on Wednesday for any last minute questions. But depending on how far or how many issues you're having, that may not be enough time, and I may be answering other people. So figure out what your questions are that you can ask me ahead of time this week, so that you got stuff for the weekend. Okay, I think Nestor had something, and then Jenna.
Yes, sir. Do you think sometime today we could go over one of the problems from homework number 2? It directly applies to what we talked about last class.
Sure. Yeah, definitely. When I get into, I'm going to get into just go over some brief review stuff, and then I was going to switch over to R. But before that, remind me of your question, and we can break that down and either answer the question or work it out as necessary.
All right, thank you.
Jenna, what do you got?
Yes, sir. So I was looking at the lab, and I'm kind of confused as to what exactly all we're turning in. Like, I know there's like the guided walkthrough one, and then there's the one where we actually do our own part of it. Are we turning both of those in? I couldn't find any like paper that said this is what you're turning in.
So what you are, it should say, and if it doesn't, or if it's not clear, I can look at it again. It should say in the instructions and the lab. But what you are turning in is there's a template file as part of the lab. That is where you put all of your. That is where you do all of your work in R. Then you are going to build that into an HTML, and that's all you're turning in. All you're turning in is your template. You're just turning in 2 versions of it. You're turning in the raw code version and the pretty HTML. So that's it. It's just the template file, but the code version of it and the pretty version of it. If you want to remind me after we get through the slides here, when I'm doing Nestor's question, I'm happy to open and show you what I'm talking about as the two files to make it clear, if that helps.
Yes, sir. Thank you.
Definitely. I keep meaning to ask you, Jen, I'm looking at that picture. I haven't seen you on camera yet. So are you, which of the two faces are you on your profile picture?
I'm holding my little sister in that.
Okay. I couldn't tell if
yeah.
that was you and a little sister or you many years ago with an older sister.
Yeah, that's about a 4-year-old picture. I think she was 4 in that. She just turned 8. So
nice. All right. Okay. So before I get started, Nestor, was your question on homework 2 like was it just a conceptual thing or was it a work it out? If it's just like you weren't clear here, I can knock it out here. If it's something like we need to work something out, then I can do it after these slides. But what is your question that you had on there?
It was just conceptual nature, like part A, B, C, D, talking about if something is simple, random, cluster, multi-stage, and whether or not it would be an effective or ineffective tool. So
okay, yeah, we can look at that. Like I said, that's mostly should be based on the breakout of the different sampling types on page, I think it's 27. But if you had a more specific question, let me get through what we're talking about today, and then I'll circle back to that, and we can bring it up and look at it specifically. Sound good?
Yep, thank you.
All right, perfect. Jenna, do you have another question, or are you just holding your hand up to testify? All right, just keep that hand up. All right. Let's start off with just looking at this. So this is a example of data summary or data visualization. So let me just go through. I'm going to use my little randomizer here. Hold on a second. Jake, you online today?
Yes, sir.
Okay, so apropos of nothing, if I give you no information, what is your best guess about what is the chart in the upper left trying to portray?
How people say pop.
Okay, so there's 2 good pieces of information that Jake has there. One, that he was able to figure out that these are mosaic charts and that it is showing us, other people call them heat maps, and it's showing us in that chart, saying, breaking out the country of what words people use, right? So this is an example of a good, or at least a relatively good summary of data, because without any explanation, he was able to understand what it was trying to portray, right? And that's what we usually, when we're doing data summary or data visualization, that's one of the main things we want to do is how can we let the data stand on its own to the highest extent possible, right? The other thing is that we learned that Jake was brought up in a good family and he correctly understands that it is called pop, and he was not sold the false lies of the South and the West Coast there that it's called soda and Coke. So, that's nothing against the rest of you who were not given the advantages in life that Jake and I were and understand that it's called pop. The rest of you just are, slightly more broken as individuals, but that's not your problem. Speaking to that, I am curious, on that lower left chart, do we have anybody in the class who actually calls those bubblers? I had never heard of that till I looked at that chart. Do we have any bubblers in the class? I had in last class, I did have someone, and he was from Boston, so he fit the demographics that we happen to have here. I actually last semester when I shared this, I had a poll online where I had people just giving answers to see how the word cloud matched up to what they had. I had to change it this semester because it turns out that I used to teach underclassmen, and I can trust underclassmen when I give them a open prompt with anonymous to answer. But it started to go downhill when I give y'all that much freedom. I believe the upper right question I phrased as, what do you call it what do you call it when you are selling things out in front of your house that you don't need anymore? And I got yard sale and garage sale and rummage sale, but I got more than 2 people who answered drug deal. And so I decided that was information I did not need to know about my cadets. And so we're just going to show the pictures from now on. Okay, so while it should stand on its own, why we want to, transfer good information, there's obviously a balance, right? So here we have, obviously, the one on the left is a little too simplistic, and the one on the right is way too busy. I put these up here not just to be funny, but to say I would be lying if I didn't tell you that I have been in more than one meeting at the Pentagon or with NATO where I have seen almost exact copies of charts like this shown by people, either things that are just so simple that I don't know why they spent the time putting on the chart, and other ones that they were so busy that I'm sure when they left their office, they're like, oh my gosh, I fit so much information on this one chart. I am going to get CGO the quarter for sure. This is the best chart anyone has ever created. And then when we got up there, everyone's like, all right, I guess that shows what you want. But the point is that it's a spectrum, right? And depending on what you're trying to show and what your audience is, that I wish I could tell you always follow these 3 steps and this is what you should output, but you're going to it's better you learn earlier in this semester than later that more and more often that's not going to be the case with statistics, especially when we're trying to apply them. You're going to get the it depends answer a lot. It's saying depending on the context and what you're trying to do, sometimes this is appropriate, sometimes this is appropriate. And so you need to think a little bit more critically about what is the data I have, what does it represent, how is the best way to represent it for what I want to get across, right? And so while I can't say here is the exact template always, we can talk about a couple of things that we should normally look for that we can kind of always help. And that's what we're going to look at this slide in the next one. So, and let me ask Ryan, are you online?
Yes, sir.
So just looking at these, what is something that you think we could do for both of these charts with respect to the x-axis? What is something that we could do better with respect to the x-axis of both of these?
So the one on the left, like I wouldn't just classify that as just like time, like I'd expand it out, like how is your money increasing over time, whether you break it up into hours, days, or something like that. And then I'm not quite sure what I would do to the x-axis specifically on the right graph. I feel like there's just so much information there that it needs to be broken up into like multiple different graphs, and like your fiscal year needs to be like categorized into months and stuff. So like that just like I feel like needs to be picked apart a lot.
Right. And I think the point that you hit on both of those is that you want to see like labels and units on the x-axis, because while both of them make it clear that the x-axis is time and that we're assuming as we go to the right, time moves forward, we don't know how fast it's moving forward. On the left, I got nothing. On the right, is that saying the entire x-axis is one fiscal year? Is each bar one fiscal year, right? And maybe if you were talking to a particular audience and you've shown them the same chart every week for the past year, they understand, and you don't need to know that you don't need to put it up every now and then. But even in that case, labeling and units are almost is one of the few universals that I want to try to see on a chart, because charts have a tendency to travel on their own. You might say, oh, I'm going to show this to the same guy every week. He knows what I'm talking about. But inevitably, someday, without asking you, he's going to go, oh, this is a great chart. He's going to copy it. He's going to post it in some other report. And he's going to be like, you know what? I'm going to be a good guy and give Ryan credit for it. He's like, chart courtesy of Ryan. And then everyone's going to look at it and be like, oh, I don't understand what this is. What's Ryan's problem, right? And so you should make sure your data, to the highest extent possible, can travel on its own, because best case scenario, you left it out on purpose because, like you said, hey, I don't need to put this on here, everyone knows. Or maybe you're just lazy and like, they'll figure it out. But the problem is, whenever I see that in any kind of meeting, I assume, my first assumption is, ooh, why did he leave that off? He must be trying to hide something, right? Because everyone, if it says, hey, time goes forward, profit goes up, in my head I go, okay, well, why didn't he put the dates on it? Because what I'm assuming is maybe the units are actually 10-year blocks, right? And everyone else in the room is going, oh, right, yeah, look how much profit we're going to make in a couple of months. And then later they go, why don't we have as much profit? And they go, oh, because the units were 10 years. They're like, wait a second, so we're not going to make profit for 10, 20, 30 years? Like, well, yeah, that's what I never said that in my chart, right? And so there's that when you leave it out, it has the tendency to look like you're hiding something, whether if it's on purpose or not. Same thing for picking ranges, right? Like if you have all this data and then one outlier way out here, it might be reasonable to zoom in and to say, so you can see this data better. But you either need to zoom out so I can see that data point, or you need to make a point to say, hey, by the way, there was something over here, or do a call out, right? Because otherwise it looks like you didn't put it in there in your mind. You're like, hey, I'm going to be helpful. To everyone else, it goes, oh, he didn't want to show us that one thing was out there, right? So having those labels avoids that problem from the get-go. Okay, so here are a handful of charts. So I'm going to kind of try to blow through these relatively quickly. Avery, am I saying that right? How do I say your name? Avery?
Avery.
Avery. sorry. We spent a lot of time with our children trying to come up with names that we thought would be unique, but at the same time people could pronounce, and we still failed. My children are Jonah, Calvin, and Hazel, and I still have plenty of people who do. And then I have people go, oh, wow, you guys must really, be into the Bible. Oh, it was 3 biblical names. And I was like, no, just one. There's no Calvin in the Bible. In fact, if you go back and read his philosophy, he was not a big guy on that. So that's cool. But anyway, yeah, no, we're big Bible. That's what it is. So Avery, can you tell me, do you recognize what type of chart that upper left chart is?
Side-by-side bar plot. Maybe.
Oh, that's the upper right. Did I say upper right? I'm sorry, I meant upper left. But yeah, no, let's stay on that. She's exactly right. Upper right is a side-by-side bar plot. So that is a awesome recognition, because it's not just a bar plot. It is side-by-side, right? Because that is a series of about 40 bar plots, right? Which is sometimes helpful to look at data next to each other. So then let me ask you the follow-up question. Do you think that chart is actually could be useful? Is that a useful chart?
I think yes.
Okay, I agree, right? Because, and first of all, let me say, this is data I made up, all right? So if you're looking at this and being like, oh man, look at how bad our squadron is, or if you're feeling good, oh man, look how great our squadron is, both of you, it doesn't matter. I made this data up. This is not real. So don't feel good or bad about yourself. Everyone, middle of the road, just ennui and angst from here on out, okay? So box plots show spread, right? So each one of those shows all the observations and how they're spread out, right? The dark black line in a box plot is the median. That's where exactly half the data points are above and below. So for example, on Squadron 1, it's theoretically saying that half the people in Squadron have a GPA above 2.9 and half of them have one below. The blue box represents where 50% of the data is. That's called the interquartile range, right? So that's showing how tightly spread it is. So for example, again, Squadron 1, everyone is half the squadron is clustered in that 3 to 3.5 range, whereas Squadron 40 is all over the board, spread out quite a bit, right? And then those whiskers are 1.5 of the range, and then any dots outside of that are people who fall even further outside of there. We call those the outliers. And I agree with Avery that this could be helpful, because I could use this. At this point, we've basically built data into some information. We've organized it so we can look at this, and we're starting to do analysis where we might look into things of saying, wow, okay, so why is 40 so low and so spread out, and 1 is tightly packed up there, or even more so 20 is got a high median GPA and they're very tightly packed, and maybe I look at it and I go, oh, the building where 40 is their Wi-Fi's been out for 2 months and they've had construction going outside their window for the entire semester. Whereas Squad 20 is in the new building with high-speed internet and all of this, and maybe 3 of their upper class are all math majors, right? And so they've got help on hand. And so okay, so that's the lurking variable here. And now I can actually do some other analysis and maybe make some moves to fix that, right? So I can use this as good analysis. Okay, let's jump over to Michaela. Are you online?
Yes, sir, I am.
So what about that upper left one? That can you recognize what kind of chart that is?
Would that be a histogram?
It is. Congratulations. You are the first person of all my sections today to actually accurately recognize that as a histogram. Everyone else I asked this morning called it a bar chart. And while it is a chart with bars, it is actually a histogram, right? The main difference between a histogram and a bar chart is that a bar chart takes a single variable, in this case, social security number, and then takes that variable and bins it into ranges and then tells us how many observations, in this case cadets, we have in each one of those ranges, right? A bar chart would be something more like what you see in the lower right. Usually it's where we take a variable and then we break up categories and give like the value of that variable for each category, or we give the count in each category. So for example, I could do another GPA bar plot where maybe the x-axis is first degree, second degree, third degree, fourth degree, and then the height is how many cadets I have in first degree, second degree, or third degree, right? That would be a bar plot because I'm showing how many I have in each one of those categories. Whereas this is a histogram. If I wanted to do a GPA histogram, maybe the x-axis would be 0 to 1, 1 to 2, 2 to 3, 3 to 4. And then the height of each thing would say how many cadets I have in each one of those ranges. So any questions on kind of the differences and the purposes of histograms versus bar charts or bar plots? Okay, so follow-up question, Michaela. Do you think that chart in the upper left is particularly useful?
Not at all.
No, yeah. I might be able to come up with a very specific case where if I worked at the Social Security Administration and I was concerned about how we were distributing numbers and what we had left for how many people were alive, maybe that would be useful. But in general, this is one of those cases where, yes, Social Security number is a number by definition, and I can mathematically do this, but knowing that the average Social Security number is around 600 million does me no good. And knowing, it's a randomly assigned number. So this falls into that category again of understanding what you can do with data, and now we're getting into what you should do with data. Because again, I can't tell you how many briefings I've sat in with where it was very obvious that someone was told to make slides for a presentation and they chose the first drop down on the Excel make a graph function, and it made a graph and they go, that looks really graphy, and they put that into their presentation. Just because you can do something doesn't mean you should do something. We all learned that in Jurassic Park. And so think a little bit about what is the best way to present the data that you're trying to get across. So with that in mind, Maxwell, are you online? I forget. Are you Maxwell or Max? What do you go by?
Max is fine.
Okay, so Max, with what if you could change something? What is one of the first things you would change about that bottom left chart? I was going to ask you what kind of chart it is, but then I realized I left the name on that. So that's a scatter plot. But what would you change about that to maybe improve it?
Well, first of all, I would get rid of the ages that can't be at the academy because they're not useful, and zooming in on the data would make those like mesh together balls look a little bit more useful. And then if it's a scatter plot, you kind of want to have some sort of a trend. So maybe put like different colors on different ages and then put them all in the same scatter plot so you can see a general trend of like a higher GPA for different age groups. Get rid of the 5.
Yeah, I agree. Yeah, exactly. I agree with everything you're saying, except maybe the phrase "mesh together balls." I might choose something different than that. But yes, I would say here the rate, obviously the range, like can't get a GPA above 4. Toddlers don't come to USAFA, right? So we're wasting a lot of space here, and it's going to make it difficult to see it. Similarly, there's almost, maybe I change some colors because usually a scatter plot is trying to show a relationship, and there doesn't seem to be any relationship here, which might be the point. Maybe the question someone asked you is there a relationship between age and GPA? And you want to show, look, it's just all over the place. No, there isn't. But maybe by changing different colors on here, I can find different insights, right? And maybe one of those insights is scatter plot isn't the best way to show this. Maybe the better way to show this is by a histogram or by a bar plot, right? So just because you can do a scatter plot doesn't mean it's necessarily the useful way to do that. Okay, and then we talked a little bit about that last one. I'd say the big thing there is kind of similar to what we were talking about before, that there's not either there's no difference or the difference is small enough that I need to zoom in on my range to actually have meaningful analysis of it. Yeah, Jenna, what do you got?
Really quick, sir, back at the scatter plot, would it also work better if you switched your axes? Like if GPA was on the bottom and then your age was on the other side, like on your y-axis, and then you could see more of a spread.
Right, and that also has to do with if you're actually going to keep it as a scatter plot is usually trying to show two variables compared to each other, and the x is usually usually what we call our explanatory variable, and our y is supposed to be our response, right? So by showing it this way, what we're saying is we're trying to say, hey, does age have an effect on determining your GPA? If I switch the axis, then I would be trying to answer a different question, right? Saying, I'd be kind of trying to present a different thing of saying, does my GPA determine my age? Which probably has, less meaning because I can't change my age on determination. But if instead of a scatter plot, I started to show it as a different chart, then that might be more useful for what you're talking about of saying, hey, here is bins of GPA and here's how the age responds to that. Yeah, John, what do you got?
So you want the x-axis to be the independent variable and then the y-axis to be the dependent variable. And then
usually.
Okay.
Yeah, and so obviously that doesn't change the data. It's just another way of displaying it. But when we display it, the assumption is that your x-axis is your independent or your explanatory, and your y is your dependent or response. That's why even back in calculus, we talk about, sometimes you would say y equals x squared or something, but a lot of times we say f of x equals, because we're saying basically y is a function of x. X just happens, and then y is possibly resulting based on x. Okay. With that in mind, if you guys got any more questions, ask them. I'm going to switch over to R so we can kind of start to see a little of this in practice. So I am importing a data set here, loans, which is just data I have. Although I did have a request last section to kind of show how I imported data set, which I did show in one of the videos. So if you guys ever want to look at those, I'm keeping those on our all students, but I'm also on the YouTube channel. If you guys want to, I was about to say, if you guys want to check out my YouTube channel, but I feel like a dork when I say that because I sound like one of the ones all my sons watch. I don't want to come off as, yeah, check out my YouTube channel, like and subscribe. We've got a comment, codes down in the comments. Get a discount on this chair back here. I don't know. I don't have a gamer chair here. I do have one at home, but I'm not. I don't think they're going to want me to start monetizing. I'm not allowed to have a Math 356 Patreon. But I can definitely step through here. Let me my background. Let me close this so that we have more. So some of you guys were talking about, hey, it's annoying to write this whole thing in here. I agree. So you do not have to do it this way. But if you want to import a data set and you're trying to find it, I highly suggest that you go over here. I'm going to delete this little broom, deletes all my variables. So now everything is fresh. If you go up to where it says import data set here, click the down arrow and say from text base, then you can search and find where is the data you want to import. I just downloaded mine, so it's in downloads, and it's right here. It's called Loan 50 CSV, and I say open. It's going to open up another window, and it says, hey, here's what it looks like in its ugly format. Here's what we're going to try to organize it in because we have recognized that it is comma delimited. I say that's all great. Up in the upper left, what do I want to call the data set in here? It's going to default to the name of the file, but I don't like that, so I'm just going to call it loans. And then I can scroll down to the bottom here and say import. And the upside is it is brought in the data set so I can manipulate it, but it is not going to always bring it in, and I don't have to go through that process all over again. So if I go down to the console here, you will see here is the line of code that it ran to import it. So I can go ahead and copy that, and then I can go back to my RMD file and just paste that into a code chunk. And now it will always, when I run this, import my data set. So I highly suggest that is an easy way of finding and getting that all important import line of code for your data set. Okay, so I've got my data set in there. Some simple functions on here. STR, that is looking at the structure of the data set that I have named loans. And all that does is it says, hey, R is going to tell me, here's all the variables that I think are in your data set, and here's what I think the data types are, right? Which sometimes they're correct. Term is an integer. That's the number of months that my loan was, because this is the loans data set. If I click on it here, it is every row, a row is one loan, right? Each column is a variable about that loan. So line number 1, that is one person's loan. And then each column tells me what state they came from, how many months the term is, whether they rent or own their home, and things like that, right? So when I go back here, it's saying, here's all the variables that I have on each person's loan. And sometimes it says, here's what I think that variable is. Term, yes, that's an integer. It's a number of months. But state, it just thinks, it doesn't recognize, it doesn't know what states are. It just says, yeah, this is just a list of letters. I don't know, NJCASC. I know that that's New Jersey, California, South Carolina, California. It doesn't know that, right? And so this is the type of thing where you go, oh, where I look at this, I go, if I want to use that, I need to tell R what it is, right? And so I would do something like loans, $, because that's how I say I want to go in the loans data set. But I want to access the state variable. So there it is, state variable. And then I'm going to say equals means gets, means it was one thing. I now want you to set it to as.factor, meaning I want you from now on to treat the state variable as a factor. Loans, $ state. And this is the weird way you have to do things in R, is that I'm saying, I'm basically I'm writing order. I'm saying make the state variable itself, but as a factor, right? And so if I run this now, I do that conversion and then do the structure. Now it says, oh, state is a factor. Yeah, there's 25 different levels, meaning my data set has 25 different states that are in here. And the examples are Arizona, California, Connecticut. It's ordered them up now. So now it knows that it's a factor and I can deal with it as such. If I go down here and run summary on the data set, then I get kind of the same thing, but it's giving me a little estimate summary statistics on each thing. Yeah, Nestor, what do you got?
Sorry, so if you go back up to the states for the STR command and you see on the right the numbers trailing after the factor of 25 levels, is that how many of each state there is, or?
Well, let's scroll down to the summary and we can see that, right? Because now that I have told it that state is before when I run this summary, state here just would have said, hey, there's a bunch of them and their characters. But now that I've told it it's categorical, it says, hey, California, there's 9. Texas, there's 5. Illinois, there's 4. And then it gets them to New Jersey and goes, and also there's 23 other states. Up here, these numbers, well, that's a good question. I've never thought about that, looked at that, because Arizona, California, those are the first couple of categories. 16, 2, 21. I'll be honest, I do not know what that is, but I will have to look that up. I could make some guesses, but you guys don't come to me for guesses. There's only 50 in this data set. So if I had to guess, My guess would be that those are the observations, that it's saying Arizona, the 16th one is Arizona, and that the second one is California, but I'm not sure. I'd have to check in on that and get back to you on it. It's a good explanation. I would say a good piece of advice as an officer. I don't know. I will get back to you on that. Is always a good answer, because I have seen plenty of things in briefings where when people get asked a question, they don't want to say, I don't know. They go, that's a good question. I know the answer, and I'm going to tell it to you right now. Here it comes, the answer. Oh boy, you're going to love it when you hear it. And it is, for sure, 13, probably. Don't check me on that. And down here we have the summary. Now, the thing about the summary is that these are summary estimates, right? So these are pretty close. I mean, they'll say, hey, for the term, here's my minimum, here's my mean, here's my median. And the mean is 42.72. But I might care about, rather than overall, something specific. And so when I run the specific, I can just say up here, I said summary of the data set loans. But I can also do summary of loans and then say a specific variable, right? So when I run that, then I get this first response right here. So that is just the summary statistics of that particular variable. So I don't have to see everything. But I can go more in detail as well. Instead of saying, hey, instead of giving me just the overall summary estimates, I want the specific, I want the minimum of that variable. I want the median of that variable. I want the max, right? And then I get the actual specific numbers down here. And so you can see a lot of them are the same, but the mean came out to 105,220.6 for the mean income. Whereas here it said, okay, yeah, I'm sorry, it's not 105,221. I didn't think you wanted it to be that specific. So you can pull that. Same thing, this quantile function. Quartiles, we don't have a quartile function in R. The median of data is, most of you guys know the median is the middle, right? So the median is the number that I have 50% of my data on one side and 50% on the other. The quartiles are the same thing, but for the quarters. So the first quartile is the number that below which I have 25% of my data and above which is 75%, right? But we don't have a quartile function. We have a quantile function, which is a general function that just says, you tell me what percent, right? So when I say quantile of a variable and I put 0.25, I'm asking for that's going to give me the first quartile because it's giving me the number below which I have 25% of my data. If I change this from 0.25 to just 0.5, that would give me the median because it would give me the number below which 50% of my data is, right? And as a reminder, on the All Students page under Files, under the instructor folders, where my folder is, I post not only my slides, but all my code. So this code file is up there. I highly encourage you guys to download it, play around with it, change some of my numbers and see how the answers change so that you feel comfortable with how these functions do. And then if there's something you like, cut it and paste it into your code and cannibalize it as you see fit. I try to add comments on here, A, to kind of be clear about what I'm doing, and B, because I ask you guys to do comments, and it would be kind of hypocritical if I didn't add comments to my stuff. Okay, in addition to these little statistics about it, I might be curious about the spread, right? And usually the statistics we use to measure spread is the standard deviation, the variance, the interquartile. No one's talking to you, Siri. The IQR and the range, right? And so as you're going to learn, R gets really creative with naming its functions. So that's SD, IQR, and range. And I can run all of those, and I get these numbers real fast. Two things to take away from here. Here's how I create them, but B, that they are very quick to do. And so when I ask you a question on a homework or a lab to find the standard deviation, I'm assuming you're doing it this way. You can do it however you want. You can do it in Excel or by hand. But if it takes you 2 hours and you go, that's not fair, we had 2 hours of homework, I say, oh no, I only intended you to have 30 minutes of homework because I assumed it was going to take you 35 seconds to type it and run it. It's up to you if you really want to spend your Saturday night. If I say find the standard deviation, and you take the data and go, okay, that number plus that number plus that number, square root minus, okay, follow the, and you want to do all that, that's fine. But I intended you to use R to do the heavy lifting on these, okay? And so that's how we find the standard deviance, the variance, the IQR, and the range. And you can see the range is 2 numbers because that is the min, and there's other ways you can do it, right? The range is just the min to the max, right? And I can see up here, there's the max, and there's the min. I could have got it that way. The IQR is basically just how much space there is between the first quartile and the third quartile. It's that box on a box plot, right? And so I could have gotten it by this third quartile minus the first quartile, but I can also run it this way. So there's a lot of different ways to do it. None of them are wrong. It's whatever you feel comfortable with. Another way to visualize the spread is with that box plot. And so here's how we created that, or what I did on, we saw on the slides there. Again, very creative. It's just called box plot, the variable that I want to do the box plot of. But then to give it context, I could just add a end parenthesis there, and I would run box plot. It would give it to me, but it wouldn't be labeled, and I don't know about it. So I add my own main title, the Y lab, that is the Y label, that adds my label to my Y axis. And then I want it to be pretty. So I change the color, which is the COL, light blue. You can use most normal colors, red, green, dark, light, but you can see a full list to change it in there. That being said, remember, the whole point of this is to make data that's easy to read. So if you start giving me stuff that is neon yellow, I might give you some messages. You are missing the point of making the data easily to read. All right, scatter plots. Scatter plots are a backbone of everything we do, so much so that the function call for them is just plot, because that is the most common plot. And so when we run it, but the rest of the code is very similar to the other ones, right? I give the variable, but because a scatter plot is based on two variables, I have to give it both of the variables, right? So this is income, or this is interest rate based on income. So I say, here's my X variable, whoops, or I'm gonna screw it up. Here's my X variable, here's my Y variable, and then I'm gonna give the X axis a label, the Y axis a label. I'm gonna give a main title, and this time I'm gonna make the color dark blue, because light blue makes these dots almost indistinguishable to see. There's a lot of other things you can change on there, like the ranges. If I wanted to change the range, let's say I wanted to change the Y axis range, I would say that is the Y lim for the Y limit, but since that is has to be from the minimum to the max, I have to say Y lim equals, and then I say C, because C is the function to make says I'm going to give you more numbers at once. I'm going to give you a vector of numbers, and so it's a column vector is why it's C, and I'm going to put two parentheses in there. I'm going to say go from 0 instead of to 25, go up to 30, and then I can rerun that, and now my Y axis goes up to 30, which may or may not be helpful, but I'm going to leave that out because I actually don't want that. Histograms, the function is just hist, and I get this nice little histogram here. This, again, I could just say histogram of the total income variable, and then I could end my parenthesis right there, and it would put out what it thinks is best. But I can add different functions to it as well. This breaks is a popular one. That says how many bins do I want. If I leave this off, if I leave this off and I rerun this, then R is going to decide what it thinks is a good idea. And so it broke it up into R. Theirs probably looks better. So I'm going to leave it as that with that number of how much I want to bring it. As a side note, the shape of this is a unimodal graph because there's one peak, and it is right skewed and not symmetric because the data trails off to a right tail. So this is a right scaled unimodal non-symmetric histogram. And then again, I got my X label, my main title, and I changed my color. You're going to find out really quickly that I like the light blue color. I don't know why. Last one, bar plots. Okay, so like we said in bar plots before, you got to be a little more careful with use of bar plots. So first of all, I ran a lot of things in one chunk of code here. And so you'll notice I got 3 different outputs here. So be aware sometimes if you do more things in one code and you don't see what you did, it might be because you had multiple outputs and you have to select which one you want to see, right? So if I just say bar plot of a single variable, R will oblige, but it is not an exciting bar plot, right? This is a bar plot of income, but it's basically just a scatter plot of income almost, right? Because every single bar there's a bar for every observation. So this is just showing me what the income of every single person is, which is interesting, but it's really just a list of data shown as a picture. It's not really a bar plot. Bar plots are usually trying to consolidate. And so what I usually want to do is a bar plot based on a table, right? That's what the book talks about. The book talks about contingency tables. And so to create a table, I group data by categorical information. So I'm going to pick two variables, home ownership and loan purpose, which again, R originally thought these were just characters. So I'm going to have to tell them, no, treat that as a factor, no, treat that as a factor. So I made them both factors. And then I can do a two-way table to say, hey, show me loan purpose by home ownership. And that's going to be this table right here, right? That's showing me a table of breaking down what you got your loan for versus how you own your home, right? I could also do a one-way table where I just do home ownership versus itself. And that's going to be this one down here, just showing me that 26 people have mortgages, 3 people own their house, and 21 rent, right? And then I went as far as to say, hey, you know what? Save that table as a variable, because I can put almost anything into a variable in R. So now homes represents that. I wrote it again here because I wanted to output it to it. If I didn't write it again, it would have said, okay, I'll store it as a variable, and then it wouldn't do anything with it until I asked it about it. But the nice thing about storing it as a variable is then I can say, hey, you know what? Make a bar plot of that of homes, which is the table, right? And now I get a more useful bar plot where it says, hey, here's a bar plot that breaks up based on mortgage, own, and rent, how many I have in each one, right? So now this is a actual useful bar plot rather than a glorified scatter plot or a histogram. Okay, I know I flew through those last 3 or 4, but I wanted to make sure you saw them. Like I said, these are under the files, under the instructor folder. So download this code, play with it, make sure it makes sense, change it, see what happens, and then ask me questions if something happens that you didn't expect to happen. All right, we got about 5 minutes left. Any questions or anything that you would like me to scroll back up on and look at here to answer on what we were looking at here in the code?
So this might be a dumb question, but are we going to have to know how to do standard deviation or median or mode or anything like that by hand?
You should at least understand. You don't need to like do it off the top of your head. You should know, be able to find in the book the equations and be able to know how to apply the equations. I'm rarely, if ever, going to ask you to do it by hand. But understand how the equation works. So if there's a conceptual question about it, or if there's like, hey, do this last step or something, that you get it. So it's not something you need to memorize or that I'm going to ask you to do by hand normally, but know where it is and where the equation comes from, what's actually happening in there, which we'll talk about more later in the course. John, what do you got?
Earlier, we talked about the difference between a histogram and bar graph, and I thought I understood it, but I don't think I do. If you can just give
the main thing here, here's a histogram, right? And so the main thing here is that, so to be clear, technically a histogram is a very boring bar chart, but it's a bar chart that we would never do. So this is in this case, this histogram is showing I have a single variable income that I have broken up into bins of saying for the variable income, how many people have an income between 0 and 50,000? How many people have an income between 50,000 and 100,000, right? And so I have a single variable that the x-axis represents ranges. For a bar chart, usually what we're talking about is that the x-axis is going to be is usually representative of different categories. And so here I'm saying how many are in the mortgage, how many are in the own, how many are the rent. So the main difference in practice is that in the histogram, the x-axis represents a continuous set of ranges of values for a particular variable, whereas here in the bar chart, the x-axis is broken into different values of a categorical variable. Does that make sense?
Yes, sir. Thank you.
Nestor, what do you got? You got a question on this, or do you want to look at your homework 2 problem?
Yeah, it was about that homework problem, if we can.
Yeah, okay. So what do you got for the homework 2? So lay it out what we can do on there.
So from that one, it was problem number 4. It's basically just like I don't understand the parts about like the clustering versus multi-stage versus, strata, the differences between those. But for some reason, like I don't understand in the homeworks why certain like a cluster was ineffective in a particular situation or the multi-stage was ineffective. Because I thought those were like better ways of collecting data than just
you're looking at is it lesson 3 you said homework?
No, lesson 2 homework, question 4.
Okay, so we're looking here and it says identify the sampling methods described below and comment on whether or not you think they are effective in these settings. So when we talk about whether or not they're effective or ineffective, so randomly sampling 50 households from this city, it's definitely simple random, and in this case we only have one option for that. But if we get to something like divide the city into neighborhoods, then sample 20 households from each. I'm going to try to find a good example. Divide the city into random sample centers. So, for example, for this one, divide the city into neighborhoods, randomly sample 10 neighborhoods, and sample all the households from those neighborhoods. So that is a cluster, but that may not be the most effective, right? Because as we are, depending on how the neighborhoods are built up, we might be getting only certain income neighborhoods or a neighborhood that overrepresents a particular ethnicity or something, right? So this case, we might want to do something more like a stratified of saying, hey, we're going to pick neighborhoods, but based on stratification, and make sure we pick a certain number from in each neighborhood, whereas grabbing all of them may not be the best choice, right? So in this case, this is definitely an example of a cluster sampling, but it is an ineffective way of doing it to achieve the goal that we wanted to, right? Which up here says the area is broken into many districts of unique neighborhoods and others with a diverse mixture. So we've acknowledged that the neighborhood breakup is not equal and random. And so we need to, doing a cluster is probably not the best way. Okay, I just realized I'm sorry, that's a short version to it, but I just realized I'm a minute over time and I get in trouble if I keep you guys. So Nestor, if you got more specific questions, send me a direct text and I will reply back to that. We can talk longer. If anyone else has something, I will put that in the comment channel as a follow-up. But for the rest of you guys, I will hang out for the next minute or so if anyone has anything. But otherwise, get out of here, look at the lab, figure out questions, and think about something besides me until Friday. And then I will talk to you guys on Friday, if not before then, about labs. Have a great Wednesday, if that is possible for your current situation.
Thank you, sir.
Thank you, sir.
Yep.